Hello everyone, so today you're going to learn about mass percent and mole ratio. Mass percent is basically defined as the percent by mass of each element in a given compound. And this can be determined from the chemical formula of the compound as well as from experimental data, the data that you obtained from experiments. Here's the formula for the mass percent. Let's say you have an element X. You can calculate the mass percent of element X by dividing the total molar mass of the element divided by the total molar mass of the compound multiplied by 100%. So this is a typical percent equation. In this case, it would be for mass. All right, let's look at an example here. Determine the mass percent hydrogen and mass percent oxygen in water, which has a chemical formula H2O. So the first thing you want to do here is to get the total molar mass of hydrogen, since we're trying to find the mass percent of hydrogen, divided by the total molar mass of water, H2O. Okay, multiplied by 100%. And then you'll do the same thing for the mass percent of oxygen. Alright, so let's look at mass percent of hydrogen first. We know that the total molar mass of hydrogen in this case is 2 grams per mole because you have 2 hydrogen atoms. Okay, divided by the total molar mass of water, which in this case would be 18 grams per mole. Alright, so now we can plug this into the calculator. You have 2.02 grams per mole of hydrogen divided by 18.02 grams per mole of the compound, the total molar mass of water, multiplied by 100%. So here the mass percent of hydrogen is 11.2%. And we can do the same thing for the mass percent of oxygen. In this case, the total molar mass of oxygen is 16 grams per mole divided by 18 grams per mole for the total molar mass of H2O times 100%, and we get 88.8% oxygen. Alright, let's take a look at another example here. What is the percentage of fluorine by mass in dichlorofluorocarbon, CCl2F2? So here's the step-by-step process. Again, the first thing you want to do is determine the molar mass of the compound, the total molar mass of the compound, and then determine the total molar mass of fluorine, the element fluorine, in this compound. And then once you find those two numbers, you divide them multiplied by 100%. Alright, so the molar mass of this compound is equivalent to 120.9 grams per mole, right? So you have one carbon, which has a molar mass of 12. You have 2 chlorine atoms. Each one has a molar mass of 35.45, and fluorine has a molar mass of 19. Multiply that by 2, and then add everything together. You get a total of 120.9 grams per mole. So that's the molar mass of the compound. The second step here is to determine the total molar mass of the element, which is fluorine. All right, since we have 2 fluorine atoms, you're going to multiply that by 2 to get 38 grams per mole. All right, now that we have these two numbers, you're going to divide 38, the molar mass of fluorine, by the total molar mass of the compound, which is 120.9 grams per mole. Multiply by 100%, and we get 31.4% fluorine, again by mass. Here's a third example. If you'd like to try this out yourself, please pause the video. Okay, what is the percentage of chlorine by mass in the same compound, C2Cl4F2? Again, here's this step-by-step process. The first thing you want to do is determine the total molar mass of the compound, followed by the total molar mass of the element chlorine, and then divide the two numbers multiplied by 100%. So the total molar mass of the compound, again, is 203.8 grams per mole. What is the total molar mass of chlorine here? In that case, it's 35.45 multiplied by 4, because you have 4 chlorine atoms, and you get 141.8 grams per mole. Now that we have both numbers, all you have to do is divide the two multiplied by 100%. So we have 141.8 grams per mole divided by 203.8 grams per mole multiplied by 100%, and we get 69.6% chlorine by mass. Alright, so what does it mean exactly by 69.6% chlorine by mass, right, in this given compound? So what this means is that if you have 100 grams of the compound, okay, in every 100 grams of this compound, you have 69.6 grams of chlorine in total, right? Or you could also say that in every 10 grams, instead of 100, in every 10 grams of the compound, you have 6.96 grams of chlorine. So again, the ratio stays the same, right? It's 69.6 grams per 100 grams is the ratio, which is actually equivalent to 6.96 grams per 10 grams. That's the definition of percentage. You have 69.6% of chlorine by mass, right? So you can write this as a ratio or a conversion factor, right? You have grams of chlorine divided by the grams of the compound per 100 grams of the compound. Or you could also write this in terms of the reciprocal, which is 100 grams of the compound per 69.6 grams of chlorine. And again, we can look at this concept later on in the next video. Alright, so now let's take a look at the concept mole ratio. So mole ratio is basically defined as the ratio between two elements in a given compound. Okay, it's the ratio between two elements in a given compound. And it could also mean the ratio between two different compounds relative to one another in a given chemical reaction equation. And the latter here, the second one, we'll talk about this in the next chapter. So let's focus on the first one here, which is the ratio between two elements in a given compound. So let's say, for example, water. We have H2O. How many moles of oxygen do we have in this given mole of compound H2O? Or how many moles of hydrogen do we have in every 1 mole of H2O? So this tells us that in every 1 mole of H2O, there's 1 mole of oxygen, because you only have 1 oxygen atom here, and 2 moles of hydrogen. Okay, so if you have 1 mole of H2O, that means that you have 1 mole of oxygen and 2 moles of hydrogen. So you can write this as a ratio, right? A conversion factor. 1 mole of H2O per 2 moles of hydrogen. Okay, you can also write the mole ratio in terms of oxygen instead of hydrogen. It would be 1 mole of H2O per 1 mole of oxygen. Or you could write this in reciprocal form. Take the inverse. Okay, so you now have 2 moles of hydrogen for every 1 mole of water. And you can do the same thing for carbon dioxide, methanol CH3OH, or ethanol CH3CH2OH. So let's look at the second one here, carbon dioxide, CO2. So this tells you that in every 1 mole of the compound CO2, you have 1 mole of carbon and 2 moles of oxygen. Again, here you have 2 atoms of oxygen and 1 carbon. And so you can translate this into moles because we're still talking about the number of atoms. Remember that 1 mole of atoms is equivalent to Avogadro's number, 6.02 times 10 to the 23rd number of atoms. So we can simplify this into mole ratio, which is 1 mole of carbon dioxide per 2 moles of oxygen. Okay, unless you're looking for the mole ratio between carbon and the compound, in which case it would be 1 mole of carbon dioxide for every 1 mole of carbon, or 1 mole CO2 per 1 mole of oxygen. Again, you can turn this into a reciprocal or the inverse, and you have 2 moles of oxygen per 1 mole of the compound. For CH3OH, we can do the same thing. All right, you have 1 mole of methanol for every 4 moles of hydrogen, or 4 moles of hydrogen for every mole of the compound. And the last one here, for every 1 mole of the compound ethanol CH3CH2OH, you have 6 moles of hydrogen. Again, you can count the number of hydrogens here, and you can just convert that into moles. All right, same thing over here. You can take the inverse and have 6 moles of hydrogen for every 1 mole of the compound. All right, so how do we apply this mole ratio concept? Let's look at this example. How many grams of fluorine are there in 25 grams of the dichlorofluorocarbon, CCl2F2? So the first thing you want to do here is convert mass in grams to moles of the compound. Okay, and then use mole ratio between the compound and the element fluorine. Right, so if you look at the compound CCl2F2, if you have 1 mole of that compound, you have 2 moles of fluorine. Okay, so that's the ratio between the compound and the element fluorine. All right, so again, the first thing you want to do here is to convert the mass of the compound to moles. And after you convert that, you use mole ratio to get the moles of the element, which in this case, fluorine. And once you've determined the moles of fluorine, you convert that to mass of fluorine because you're trying to find the mass of fluorine here. All right, so we have 25 grams of the compound. We convert this to number of moles. So in that case, we will need the molar mass of the compound itself. Okay, and the molar mass of the compound is 120.9 grams per mole. Okay. The second bracket here is basically the mole ratio between fluorine and the compound, right? You have 2 moles of fluorine for every 1 mole of the compound. And then we're going to add another bracket here, which would be the molar mass of fluorine, because we're now in step 3, we're converting the number of moles of fluorine to mass of fluorine in grams. All right, so you can see the units here canceling out, leaving you with the units in grams. All right, so we have 7.86 grams of fluorine. Let's look at another example. What if you're trying to find the mass of chlorine in grams instead of fluorine? So now we're looking at chlorine here. Again, you're going to do the same thing. Convert the mass of compound to moles. Okay. And then from moles of the compound to moles of the element. So in this case, you're going to use mole ratio. This time is the mole ratio between chlorine and the compound. All right. Once you've converted it to moles of chlorine, you can now convert this to mass in grams using the molar mass of the element chlorine, which is 35.45 grams per 1 mole. So you can see the units canceling out, and you're left with mass in grams. So multiply all the numbers up top divided by all the numbers in the denominator, and you will get 14.7 grams of chlorine. Alright, so that's all for today. Thanks for watching. If you liked the video, please subscribe, and I'll see you next time.